Hello everyone and welcome to the CEC and AMI guys. Strength of material part 3rd. We will discuss how to find the impact forces, impact deformation due to the impact loading. So let's start with the impact loading. So what do you understand by the impact loading? Basically the impact loading are those loads which are acting for the short period of time. Acting for short period of time. Acting for the short period of the time is known as the impact loading. Like the IC engine piston connecting rod during the power stroke, a spur gear using the higher velocity, a spring used in the shock absorber, component used in the forging, punching operation, etc. are the example of the impact loading. So just take an example here. And a spring is placed and a load of the 2 kg at a height of h is dropped. So how much energy will be transferred to the spring due to the impact? How much this will deflect is termed as the impact loading. So there are some of the basic steps which you will follow and you will find the impact deformation and the impact stresses. So first, for this type of the question, follow the step number first. Assume the given impact load as the static load. Assume the given impact load as the static load. The step number second, determination of the static deformation, that is the delta static, by using the determine delta static using the Sohm equation. Now the step third, is the calculate the impact factor. Calculate the impact factor. So impact factor is given by the 1 plus under root of 1 plus 2h upon delta static. Here h is the distance between the object 1 and object 2. So from here you will find the impact factor. And the step 4 says that the delta impact, you are required to find the deformation due to the impact load, which is equals to the delta impact is equals to delta static into impact factor. And if you want to find the stresses, then use this equation. First find the stresses due to the static load by the Sohm equation, then you can use the relation delta impact stress due to impact load is given by the impact factor into stress due to the static loading. So by using this 5 step you can calculate any of the impact loading numerical. So here I am going to discuss a simple example. So let's take an example. You are given that the a simply supported beam of the span of length L, a load W is at a height of h from this beam surface, and it will impact at the midpoint of the beam at the L by 2. So follow the first step. Convert this simply supported beam and impact load to the static load. So assume the load is static load W. Due to this, the deflection will be the delta static. Got it? So from here, first step is to convert the impact load to static load. Now find the static deformation, which is equals to WL cube upon 48 EI in case of a simply supported beam and the load is acting at the midpoint. All this type of the deflection formula we have discussed in the part number first. So for the deflection formula, refer SOM video part first. Okay. So here we have calculated the delta static is equals to WL cube upon 48 EI. Now calculate the impact factor. Impact factor is given by the 1 plus root of 1 plus 2h by delta static. So here we have calculated the delta static, put the value here and calculate the impact factor. The next step is find the value of the deformation due to the impact load, which is given by the delta static into impact factor which we have calculated here. So from here you will find the value of the delta impact. The step number 5, calculate the static stress, which is equals to the maximum by ZNA for this case, which is equals to the WL by 4. Here W, so the reaction will be WL by 2. So the moment will be the WL by 2 into L by 2 distance, which is equals to WL by 4 divided by the polar section modulus. From here you will find the value of the static stresses. To find the impact stresses, just multiply the static stresses into impact factor. You will find the impact stress value. So this is the procedure to find out the impact deformation, impact load due to the impact loading. So this is all about the impact loading numerical and its concept. So in the next video we will meet with the new concept and the new topic. For the more video update, subscribe our channel. Thank you.